Hey guys, in this video I'm going to teach you on how to integrate definite integrals. So here's the formula. The integral from a to b of f of x dx is equal to capital F b minus capital F a. There is no plus c here because it's indefinite. Now, let's try an example. How do you integrate the integral from 1 to 2 of 2x dx? How do you do this? Now, we know how to integrate 2x. This x squared, just that. And normally we would add a plus c, but we don't. So it's evaluated from 1 to 2. X equals 2, x equals 1. Do you do this one first, and then this one second? First, second. So therefore, we have 2 squared minus 1 squared, which is equal to 4 minus 1, which is 3. Let's try another example. The integral from 0 to 1 of x squared dx. Now, we know how to integrate this, and then just raise it from 0 to 1, x equals 1, x equals 0, first, second. 1 cubed divided by 3 by 0 cubed divided by 3. So, 1 third minus 0 thirds, 0, sorry, we have 0. 1 third minus 0 is 1 third. This is going to be the answer. Now, let's make it more complicated. What is the integral of the square root of x times dx evaluated from 2 to 3. So let's write this as this. So it's going to be a rational exponent. So this is going to be 2 thirds x to the 3 halves, and then evaluated from x equals 3. No, x equals 2 to x equals 3. Keep in mind, first, second. Okay. So we have 2 thirds times 3 to the power of 3 halves minus 2 thirds times 2 to the power of 3 halves. So now, should we simplify this? But I don't know if we should simplify this. Okay, you know what? Just keep it like this. We can just keep it in this form. It's fine. Unless we just need to get a correct answer, that's all. Right here. Okay. Now let's try this problem. Integral evaluated from 1 to 3 of x plus 3 squared dx. Now we can either use u substitution or we can use FOILing. Now let's do both of them. So first, let's use the FOILing method. This is going to be integral from 1 to 3rd of x plus 3 times x plus 3. And it's FOILing now. So x times x is x squared. X times 3 is 3x. 3 times x is 3x, and then 3 times 3 is 9. So now we're going to add these two to simplify. So we have x squared plus 6x. And then we have 1 plus 9. And keep in mind, we still have a dx term. So therefore, you have x cubed divided by 3 plus 6, but 6x squared divided by 2 will be 3x squared, so 3x squared plus 9x evaluated from x equals 3, x equals 1, x equals 3. First, second, okay. 3 cubed divided by 3 plus 3 times 3 squared plus 9 times 3 minus 1 to the 3rd power plus divided by 3 plus 3 times 1 squared plus 9 times 1. So, let's see what we can do. So 1/3. Okay, I know what we should do. So 3 to the 3rd power, so 3 times 3 is 9. 9 times 3 is 27. 27 divided by 3 plus 3 squared is 9. 9 times 3 is 27. Plus 9 times 3, 27. Minus 1/3 plus 3 plus 9. We should simplify, I guess. It's pretty easy. I'm not going to do it for the hard term because it's going to take a really long time. Because for this video, we're only learning calculus. And for algebra, that's when I'm going to simplify those expressions. Because we need to learn that in algebra. Okay. 27 plus 27. This 2 minus, and these 2 addition. Okay. So you have 26 divided by 3. Okay. 26 divided by 3. Plus, okay, plus 47, so 27 plus 27, so 20 plus 20 is 40, 7 plus 7 is 14, and we get 54. And minus 3 plus 9 is 14. So all we need to do is to subtract this. So we have, okay, so we have 40 now. So this is our answer. Now let's use U substitution for this problem now. So the integral from 1 to 3 of x plus 3 squared dx. Okay. So we set u equal to the highest degree term, so u equals x plus 3, and we get du is going to be 1 times dx, divide both sides by 1. You get dx equals du over 1, which you will simplify to get dx equals du. If dx equals du, so we're going to have this now, basically. So we have u squared times du. And for a definite u substitution, you need to change these two with this expression. So let's change this. So u equals 6 for this part. 1 plus 3, u equals 4. So you have the angle evaluated from 4 to 6 now, because you can't just do the u substitution because you replace it with u, and then it's going to get too complicated. So that's why I need to change it with these x values here. So this is what we have now. Okay. So you know how to integrate this. Just u cube 4 to the 6. So x equals this. X equals this. First, second. So it's equal to 6 cubed divided by 3 minus 4 cubed divided by 3. So, okay. 6 times 6 times 6, okay. 6 times 6 equals 36, so 36 times 6. Let's do it here. 36 times 6. 6, 36. 6 times 3, 18, 18, 21, 216. 216 divided by 3 minus 4 times 4 equals 16, and then 16 times 4 equals 64. Wait, let me check again. 4 times 40. Okay, yeah, 64, okay. So now I just need to subtract these. So 216 minus 64. This is what we have, 142 divided by 2 for that answer. So this is how you do it. Wait, oh my gosh, I made a mistake. We're supposed to replace u now when we get this, and then we integrate it like this, because how is x gonna be? Okay. It's fine, let's just erase this. Okay, let me fix my mistake so you guys don't make mistakes because I'm teaching you guys. Okay. So replace u and the term will be x plus 3. So we have x plus 3 cubed divided by 3 evaluated from x equals to x equals 6. Okay, so this is what we have now. Because u is equal to x plus 3. Okay. Now this makes sense. Okay, good. So 6 plus 3 cubed divided by 3 minus 4 plus 3 cubed divided by 3. 6 plus 3 is 9 cubed divided by 3 minus 4 plus 3, which is 7. So 7 cubed divided by 3. Okay, we have to do some long multiplication here. 9 times 9 is 81. 81 times 9. 9 times 1 is 9. 9 times 8 is going to be 72. 729 divided by 3. And then 7 times 7 is 49. 49 times 7. So 7 times 9 is going to be 63. And then 4 times 7 is going to be 28. So 28 plus 6 is going to be 34. Okay, now let's write our final answer here, but we need to subtract these two. So 729 minus 343. So 9 minus 3 is 6. It's 6. 2 minus 4 is 6, so you got 12. 12 minus 4 is 8. And we have 6 minus 3, which is going to be 3. So we have 386 divided by 3. I mean, let's see if we can simplify this. So 80 divided by 3. Can we simplify that? I don't know. Okay. Wait, 45 for 40. Let me, 1 second. Just give me. Okay. Okay, we can't. So, let's do another one. Let me think. Okay, I got an idea. Evaluate this. The integral of the square root of x plus 2 dx. So we can either use the power rule or we can use these. And don't think that I forgot. There's definitely no reason. Okay. Let me just check for mistakes because I know for my last video I had no mistakes because I replaced you and everything, but for this one I can see that I did no mistakes as well. So that's good. Okay. So therefore, now let's solve this. Now let's use u substitution first. So u is equal to x plus 2. Okay, u equals x plus 2. Okay, keep that in mind. So du will be 1 dx. Divide both sides by 1, you get du equals dx. And if du equals dx, we need to do this one. So square root of u times du. Now we have this, we need to replace the terms. So we have integrate. So u equals 2 plus 2 and u equals 1 plus 2. So we have 4, we have 3. So it's evaluated from 3 to 4. Integrate u du. So this is going to be 2 thirds u to the 3 halves, evaluated from x equals 4 to x equals 3. So we have to, oh my gosh, 1 second. Wait, what? Let me just erase this. So we have 2 thirds times 4 to the power of 3 halves minus 2 thirds times 3 to the 3 halves. Okay. Now, 4 to the 3 halves, how do we do that? Now 4 to 3 halves, we can write this as 4 to the 1 half. And a 1 half times something, so 1/2 times something equals 3. 3 halves. So we have 2/3 remaining. But we can't just do that. Wait, actually, if you add this, you will get 3/3. But wait, 3 halves. So 3 halves, so 1/3. Okay, so basically we have 4. There's 3 halves, which will be 4 to the 1/2. 1/2, so 1. So we have 3. No, just give me 1 second, sorry. Fiesta! Okay. Yep. Okay. I'm sorry, guys. So I'm just gonna do this part in case you just forgot how to do algebra. I'm just gonna teach you this really quickly. So you have 44 cubes, so we have 2 cubed, and then 2 cubed is 8. This is how you evaluate these type of rational exponents. Okay. Now, let me see. 1, 2, 2. Okay. I use the power rule to do this now. So if we use the power rule, you're gonna get the integral from 1 to 2 of x plus 2 to the 1/2 dx. So, as you can see, it's gonna be pretty hard to solve this. Like we could still use u substitution, and if we just do it like this, it just cannot do this. You would have to use a different technique. Because you cannot use the power rule in this case. You need to like do a lot of simplification more. It's gonna get complicated. Just so you have like 2x squared plus 4x minus 8 equals 0, and it just keep plugging in numbers. Like this is how it basically is. So let's just use substitution. U equals x plus 2. du equals 1 dx. Divide both sides by 1. You get du equals dx. Integral 1 to 2 u to the 1/2 du. So u equals 2 plus 2. U equals 1 plus 2. You have u equals 3 and u equals 4. So, this is equal to the integral of 3 to the 4th u to the 1/2 du, which is gonna be 2/3 u to the 3/2 to the power of x equals 4, and the power of x equals 3 to the power of x equals 4. So, no, evaluate of x equals 3 to x equals 4. Okay, my bad. So this is first, this is second. So our answer is gonna be 2/3 times 4 to the 3/2 minus 2/3 3 to the 3/2. Notice that we get the same answer. Okay. Now, let's try a few more examples. Okay. Let's try some subtraction problems. Evaluate this. So you know this is 3. Let's just do this in our mind. So 4x squared divided by 2. If you divide 4 into 2, it's 2x squared, so 2, 1, 2, 2, 1. 1 to the 2, 1, 2, 2, 2. 2 minus 0, so you get 2. 3 minus 2, 1. If we did this mentally, let's try it to do... Now that we did this mentally, let's try to do it in here. Because some of you guys didn't get what I did, because I learned this by my calculation. So we have 2x squared divided by 2 divided from 1 to 2 minus 4x squared divided by 2, and then from 0 to 1. X squared divided from 1 to 2 minus 2x squared divided from 0 to 1. This is equal to 2x 2 squared minus 1 squared minus 2. Ooh, okay, 2 times 1 squared minus 2 times 0 squared. Plus 4 minus 1 minus 2 minus 0. Minus 1 is 3, 2 minus 0 is 2, so 3. 3 minus 2. Okay, here we get 1. 3 minus 2 is 1. Okay, let's try our final example. Let me think of a hard example. Okay, I got it. Evaluate this. Okay. Evaluate this. Okay. If you don't know limits and derivatives yet, I'm gonna upload more videos about it, like later, and I'm gonna soon upload some autonomy and psychology videos about the science. I'm gonna also upload English videos and much more stuff. Okay, let's just evaluate this limit, like just right here. So we're gonna evaluate the limit as 2n plus 4 divided by 3s minus 4. Multiply both sides by 1 over n. Cancel this to the limit as n approaches infinity. 2 plus 4 over n divided by 3 minus 4 over n. So keep in mind 1 over infinity keep in mind the limit as n approaches infinity. 1 over n is always going to be 0 because 1 over infinity is 0. And 1 over infinity is 0 because 1 divided by 2 is 0.5, and then 1 divided by 3 is 0.3 continuous, and 1 divided by 4 is 0.25. It's going to get smaller, so 1 over infinity is 0, and that's why. So therefore, we now will have 4 divided by infinity, which is 0, and then minus 4 divided by 0, so 2/3. We have 2/3. So we have the integral evaluated from 0 to 1 times the derivative of d over dn of 2/3. Okay. What's going on? Okay, here. Okay, what's going on? 2/3 dn. Now keep in mind, for these type of problems, we could also use something called the fundamental theorem of calculus, so FTC. And if you want to check out those videos, I'm just gonna use like what we have this evaluate like this. But for FTC, I'm gonna explain that to you guys in maybe another video, because for this video we're only focused on definite integrals. So I'm just gonna simplify like this. But if you want to learn how to accurately do it, I'm gonna show you in another video. And you remember from the last video we have an integral of 5 over x to the fifth of dx times dx. We could have used substitution to do it, and I used normal method. And from here we have used substitution. And if you guys want to try that problem, you guys can show me the answer in the comments, and I can tell you if it's correct or wrong, just for extra practice. So we have the integral from 0 to 1 the derivative of 2/3 is going to be 0, so 0 to the n. Okay, so we have 0 times n. 0. Yeah, 0 times 1 minus 0 times 0, which is going to be 0 minus 0, which is going to be 0. So this is what we get if we use FTC as well, but I use this method. So I hope you guys enjoyed my video, and I hope you have a nice day, and goodbye, and I'll post more videos tomorrow, okay? Like one more video. Every day I'm going to post one video. Okay? And also let me know if I make any mistakes, because I always check it. I check it like a lot of times, and I know that I didn't make any mistakes. So, goodbye.